Absolute value represents the distance that something is from 0. So, for example, 7 is 7 units from 0. If I have the absolute value of something equals 10, they're basically asking what number is 10 units away from 0. So what number is 10 units away from 0? 10. Is there another number that's 10 units away from 0? Negative 10. What number is 0 units from 0? 0. Is there any other number that is 0 units from 0? Negative 0, which does not exist. So no. How about what number is negative 1 units from 0? 1 is 1 unit from 0. Negative 1 is negative 1 units from 0. Or sorry, negative 1 is 1 unit from 0. No solutions.
Oh, you're right.
Basically, when you take the absolute value of something, you end up with a positive number. Absolute value does not equal a negative number. So you may want to write in your notes that the absolute value of stuff cannot equal a negative number. Absolute value must always equal a positive number. All right. So here's our first equation. 3 times the absolute value of 2x minus 5 plus 4 equals 7. Okay, the biggest rule with absolute value, you cannot distribute into absolute value. So you see this 3 in front, and I know some of you are like, ooh, I want to distribute that 3. I want to multiply that 3, but you cannot, so don't do it. Instead, what could we maybe do? We can subtract 4. That will give us 3 times the absolute value of 2x minus 5 equals 3. If we can't distribute, how do we get rid of this 3 times the absolute value? Divide both sides by 3. Absolute value of 2x minus 5 equals 1. So your first goal with absolute value equations is to get the absolute value bars by themselves. So if there's anything added or subtracted after the absolute value bars, you need to get rid of that first. If there's anything multiplied in front of the absolute value bars, you need to get rid of that. Get those absolute value bars by themselves. Once you get the absolute value bars completely by themselves, now you need to think about absolute value equals the distance. Where on the number line are we 1 unit away from 0? At 1 and negative 1. So we need to write 2 equations. 2x minus 5 equals 1. 2x minus 5 equals negative 1. And solve both equations. You have 2 answers. So take a moment and solve both of those. That looks like a negative. That's not a negative. So we have 2 solutions, x equals 3 and x equals 2. On this example, if you don't want to write this down, if you just want to watch, that's fine. We're probably not even going to finish this example. We'll just start getting this set up. So, do you notice that there's no number in front of the absolute value bar, and there's nothing added or subtracted after the bars? So the bars are by themselves. So our next step is write 2 equations. The 2 equations would be 2x plus 3 over 5 equals 5. And what does the other equation look like? Okay, and the only thing that I want to make sure you all see is what would your next step be? multiply by 5. You need to get rid of that big long divided by 5, so you'd multiply both sides by 5, and then you'd finish solving it. Give me a thumbs up, thumbs down. How do you feel about absolute value equations so far? Great. Let's move on so we can make this video nice and short. Absolute values on both sides. This is something that we honestly did not cover in Algebra 2 last year, so this might look a little bit new. To solve this, you still need to write two equations. The first equation is exactly like what's written without the absolute value bars. So 3x minus 4 equals 7x minus 16. Anyone want to be super brave and take a guess what the other one looks like? Close. We're gonna keep 3x minus 4 the same. Negative 7x plus 16. So we kept the first part the same, but in the second equation, instead of positive 7x, we have negative 7x. Instead of negative 16, we have positive 16. For some reason, every time I try to highlight, it doesn't let me very well. Okay. So I'm going to pause the video. If you're watching the video, you should pause the video too and take a moment and solve both of these equations. Once you have your answers, then play the video and we'll see what we do next. You might notice on this slide that it says check your answers. So once you have the answers of 3 and 2, here is how we need to check the answers. You are going back to the original equation, and you can do this mostly in your head. So take 3 and, no, didn't want to do that. Take 3 and plug it in here and here, and let's see what we have. So 3 times 3, 9. 9 minus 4. So on the left side, we'd have the absolute value of 5. On the right side, 7 times 3. 10 minus, 7 times 3 is 21. I'm just blindly agreeing with whatever my students say. You all could tell me like 5,220 and I'd probably believe you. 7 times 3 is 21. 21 minus 16 is 5. Does the absolute value of 5 equal the absolute value of 5?
Yes.
Yes, it does. So that is a solution. Now let's try 2. 3 times 2 is 6. 6 minus 4 is 2. 14 minus 16 is negative 2. Is the absolute value of 2 equal to the absolute value of negative 2? Yes. It is. Because the absolute value of 2 is 2. The absolute value of negative 2 is 2. So yes, they are equal. Okay, this one, let's set it up quickly. We aren't going to finish this one. What's one of the equations? X plus 5 equals?
X minus 11.
X plus 11. What's the other equation? X plus 5.
Oh, you don't flip both?
But we do flip both of these. So negative x minus 11. Okay. Now, when I solve this first one, the x cancels on both sides, and I'm left with 5 equals 11. Does 5 equal 11? No. That portion of the problem does not give us a solution. The other side, we'd add x to both sides. We'd get 2x plus 5 equals negative 11. We'd get 2x equals negative 16, so x equals negative 8. And I hope you trust me. If you test negative 8, it works. Ta-da! Okay, so one more time. Get the absolute values by themselves, then write two equations. If you have an absolute value on both sides, one equation is exactly what is given to you without the bars. The other equation, keep the left side the same, On the right side, it's like you're multiplying everything on the right side by -1. Yeah, put the shards back together. There we go. Sometimes I get annoyed by my computer, but it's okay. It's a nice piece of technology. We love it. We learn from it. It's cool. I think I'm done now. Bye.
Yeah.
It's still recording.
Darn. I hate this thing.
Welcome to my 5th hour class. There's something.
Ah.